Hi, good morning. My name is Francisco, and this is Josh, and we're going to be presenting on our research project that we've just been working on for the past like a year or so at Concordia Library, and it's about deploying a conversational agent using LLMs and comparing those, but like as a real academic in an actual academic setting. If I can make this happen. Okay. So for this project, we have two main objectives. One was to actually implement a retrieval augmented generation based system that can answer reference questions. And this is kind of on point because this RAG, as we're going to refer it from now on because I can't pronounce that many times, it's one way to mitigate some of the issues that were highlighted in the previous talk. In the sense, in terms of like we'll see now, we privilege like information from a database instead of from the sort of like knowledge or the embed knowledge from the language model. And the other part of the project was to develop an instrument and a protocol to evaluate this chatbot to see if it's actually useful for users, which is it's not so much that we can make it, it's like, is it any good? That's kind of like the two questions we were thinking of. And this is the project team. It was composed of 3 librarians. Joshua is here with me, also Megan Olivier, 2 research assistants, one from journalism, one computer science, and myself as the software developer. This project was funded initially by an internal research grant from the library that added as a seed grant. And with that, we were able to apply for a more like a slightly bigger grant from the Concordia Applied AI Institute. And we work on collaboration with industry. So our nonprofit partner for that particular grant was the Cinémathèque Québécoise, which we also developed for them. We reuse, kind of like repurpose what we learn and provide them with and other tools for the use. So quickly, this is our basic RAG stack, and I'm just going to go through it shortly. So provide some context. Yes, some of you are familiar with this already, probably, but basically it has so the RAG system has 4 main and distinct sort of phases. And the first one's being indexing. And what we do, did you see? Okay. So what we did here, we have to create first like a knowledge base for the robot, okay, for the chatbot. And the way we did it is we manually scrape our own website. And we did that way because we want to have full control of what was in the knowledge base. So we know that if an artifact and if an error shows up, it's not due to information that is missing. So we have like we actually know what's in it, kind of like pick the brain in a way. And once we have that knowledge base, we are getting it in our own like an proprietary system. It's not proprietary, it's open source, but it's our own system that we developed. And with that, we then do embeddings, and we're going to go to the details of that. And the end result, we have something called a vector database out of it, which basically it works like a search engine. You can see it like as an index. So that's the indexing portion of it. Then the retrieval is when the user prompts the questions, instead of going straight to the LLM, like we do when you use ChatGPT, it first does a search in this vector database. And then those searches are and then fed to the LLM. So that's the retrieval. Then it comes to the LLM, and that's the generation part. And then with that, it will privilege that information instead of its own kind of like knowledge that it has, and then it crafts a response out of it. So that's the basic sort of a functioning or flow of information within the schema. And one of the things that happen is even if you do that, one of the things this LLMs perform very poorly is that it makes up links, which is very bad for us because in reference, you want to provide links that do work. And ideally on the library, you want links that are already like the proxy, and there are own links, so people can actually access the databases. So to fix that, we take the response and we went through like a very aggressive method. And this is no AI. We just basically delete all the links and then try to match. We have a big database that we created from our loop guides and other stuff that we had. So we created a link with resources, names, and links. And then we just like enrich that. And that result would then refeed it to the LLM to rewrite. And then that's what he gets to the user. And that's how we managed to overcome that issue. But if you see, that kind of like, this is highlights like kind of like the kind of things you need to do to have like an actual working thing. It's not just instruct a general LLM and it will just work. Like it requires a lot of fine tuning and stuff like that. So.
Okay, I will give you this is a high level overview of our project. Actually, early on, we referred to the Library of Congress as this AI planning framework, and that was useful for developing some use cases internally. But we took those ideas and we created a questionnaire of questions that would be used as prompts. And I'll talk more about that in a moment. Then we defined a rubric to grade the answers, so the output from the LLMs. And we did that. We had one person, so one of the research assistants would take each question, put it into a model, engage with that chat with the model, and record the information into a grid. And so the models that we used to do this were OpenAI's ChatGPT 3.5, which at the time was current. Of course, they have new versions now. Google's Gemini, Microsoft's Phi 3, which is actually a small language model. And we don't have it listed here, but there's also Llama 3 from Meta, which we've used. We're still evaluating its responses. And so we used the rubric that we defined to score these responses. Essentially, the three librarians, we were relying on our experience answering these questions in the past, having staffed the chat on the library website, so the embodied humans chatting, not the AI, and from in-person questions. We also had the one grad student for some other perspective, and I just want to note that in grading these responses, just to reiterate, we were looking at our protocol for evaluating the responses. And so it was enough that we had these people to identify, where the protocol worked or didn't. If you really wanted to evaluate the quality in depth of the responses, you'd probably want to have a bigger group of people evaluating them. These are the prompts. There's 14 of them that we use to interact. And these came from, interviewing librarians about the types of questions that we've encountered in the past. Probably for a lot of you, these look like common questions because they do come up frequently. And there's a few things that you should note about these questions. One is that every one of these is answerable based on the content from our website. So what Francisco was just describing about the knowledge base that we made of content, we knew that there would be a way for us to evaluate the accuracy of these because the information came from what we actually had on our site. There's another point about these questions, which is when you ask what's useful here, if the chat tool is just providing responses to like an FAQ question, then that's not really adding any value to what it can bring. So you'll notice some of these questions are things that are straightforward, but others require a little bit more depth. And so one of the hallmarks of these generative AI chat tools tends to be that they give this appearance of having a back and forth interaction with the user. And so that's one area where you might think maybe this could add some interesting value. This is the rubric that we used. And so I'll say a few things. It's not really important to read all of this, but I'll describe what was going on here. So we started with Katie Lay's rubric. She has an article evaluating the ChatGPT responses based on three things, really. Those were accuracy, completeness, and further assistance. And so we took that as our starting point. We added some gradation to it. And then we also added some other areas, namely groundedness and elicitation to this model. The reason that we added those things goes back to what we were trying to do with evaluating the usefulness of it. So let me just run through what these mean. Accuracy, we were looking for the fact that the model would deliver accurate information. So it's not making up things that are false. We're looking for responses that are true, essentially. Groundedness refers to it getting that information from the knowledge base that we had built. So again, what Francisco described, that information should be Concordia specific, coming from our site, and not just what the model was already trained on when we got it. Elicitation was looking at whether or not the model could ask the user for clarity or to be more precise about the question, to do some of those kinds of things that you might expect in a reference interview if it had that kind of an interaction. Completeness, some of the questions you may have noticed had multiple parts to them, so we wanted to see that it was answering all of the question and not just a portion of it, leaving the user in the lurch. And then further assistance, we were looking for the model to say, contact a librarian for this, or to provide a link to some way that they could get more help. And so these were all important factors for us to consider. I want to reiterate that in this, we were trying to create a protocol for evaluating these models. If you really wanted to implement a generative AI chat system, you would want to look at a lot more than just this. So I won't go into detail about all of that, but you would want to look at things like accessibility, energy usage, liability, jurisdiction, content ownership, licensing. Some of these models are more open, whereas others are more restrictive. So these are all kinds of things that you would have to delve into more.
Yeah, just briefly, when I look, one of the things to see, well, what I want to show with this slide is that whether the instrument allows us to discriminate between the models, because an instrument is only good if it allows us to make a decision. So we compare these three models, like, does the instrument tell me which model performed better? And in this graph, you can see that it did. And you can see, for example, like in each of the fields, basically this graph, like the bigger the area, the better the model. And you get like you fit in this pentagon, which defines dimensions defined by the rubric. And you can see like how OpenAI actually performs better. And you can see, for example, that the small language model is good at some stuff and which one is better than the others. So we were happy in the sense that the approach seems to be able to allow us to tell which model is better than the other, which is an important feature. And this graph shows, this is the standard deviation, like it's an average of the standard deviation of the answers. And this is a measure of dispersion. And what you want here is the bars to be about the same height and as low as possible. Okay, so and what we wanted to do with this in this study, in this analysis, was to see which dimensions were better defined. It shows the quality of the grading of the rubric, and we consider like anything below 1 to be acceptable. That means because it's a 1 to 5 grade, kind of like Lucas scale. So if the answer is a 3, like all the answers were between 2, 3, or 4, which is kind of okay. Should be lower than that ideally. And you can see here that the dimensions were, some of them they're not the same. So not all dimensions were as well defined as others. And we do seem to have a little bit of an issue with elicitation, that the way elicitation is defined seems to be a bit fuzzy. So we may need to rework like that specific dimension, how it's graded, because people interpret it in different ways, like having like such and it's also very uneven between models. So that's not very good. Yep. So that's, here's the conclusion.
And we're running out of time, so I'll quickly conclude here. So just a few points to bring up. The RAG implementation was a successful thing to do, but because it, processes change, website content change, and that was a manual process. So that's going to require ongoing maintenance. It turns out that smaller language models might work as well as larger ones, so that's something to explore a bit more of. The evaluation of the performance, even though the graphs that Francisco just showed had some consistency to them still, as librarians, when we're looking at the output from these models, there would be certain things that we'd interpret a little bit differently. So we want to iterate on our protocol and our rubric to maybe provide more guidance so that we could have a closer match in the way we perceived these outputs. And the last thing I'll say is that it did bring up a little bit of soul searching for us in terms of how we saw what a good quality response to a user's question was from a human standpoint and from a machine standpoint. And so, you could think of it if say a student needs help with something, it's after hours, there's no librarian, nobody around to staff. Is it okay to give them access to a tool that's maybe not quite perfect, but is just good enough to give them a little bit of help? Or do you take a perspective where, okay, the tool, because it can't really elicit things and have that kind of a reference interview process, it may give a factually correct answer, but it's actually a misleading answer because it's the user isn't able to see these other perspectives or paths in their research that might come up with talking to a librarian. And there are a lot of other considerations like that this has kind of brought to light for us. So thank you.